professor, physician, epidemiologist. I am Dr. Sri Banerjee. When I say this, I mean it. The Centers for Disease Control is a treasure trove for public health information. Hi, I'm Dr. Sri Banerjee, core faculty for the College of Health Sciences and Public Policy at Walden University. And I'm going to be going over this an additional interactive dashboard known as the National Report on Human Exposure to Environmental Chemicals. And so, as it turns out, there are biomonitoring data tables. And when I tell you that NHANES has all sorts of information, I mean it. The National Health and Nutrition Examination Survey is a treasure trove for information surrounding toxicity of potential exposure hazards. So what you can do is you can either just start going in by the biomonitoring data tables, or you can start by looking at what's new. And there's some word about ethylene oxide. There's some information on cigarette smoke that's been recently conducted. So there's some ideas for different types of analysis here. I'm just trying to see. Oh, there's even a how-to guide for biomonitoring, which would be maybe an interesting little piece to read before you start talking about before you start looking at the exposures. That is if this page ever loads. And seems like service is unavailable at this point. So would be nice to look at a how-to guide before going into and going in and diving into the biomonitoring data, but as oftentimes is the case, these things do not work when you want them to. So I'm just going to go ahead and dive into this. Actually, here you might find more luck. I've actually made sure this works already. So CDC National Report on Human Exposure to Environmental Chemicals. Now this is looking at either looking at NHANES, National Health and Nutrition Examination Survey, but looking at either whole blood. And here's the value of this. I'm gonna emphasize this a little bit more here. This is not data that has been collected by a patient that has told you these are the values, or that has told you these are the conditions that they have. These values, this information, this was actually derived from physical exams, from blood samples, urine samples, all of these things that were collected from actual patients. So let me put a plug in here for using this data set. All of the hard work, the hard part has been done. The data collection from patients, that part takes millions. That part has been done. So if as data analysts we do our part and start to look into some of these effects and understand the effect of exposomes, then we can really make strides. So this is actually a reflection of exposomes, human sets of exposures within chemicals. So you have table viewer 1, table viewer 2, and you can do a search. This one is for acrylamide. And then so there's up to 6 data tables that can be loaded at the same time. You can compare kind of what acrylamide is to maybe another chemical that you can think of, and work on it that way. So let's see what can be found here. So we'll do step 1, which is analysis of whole blood, show chemical list. Might want to do a PFAS. And so these are the totals, and it's disaggregated. It's total population, and then it's disaggregated by age, by sex, and then by ethnicity. So it's pretty neat information. So let's compare PFAS with, say, table viewer 2, another chemical, PF. PFBS maybe. There's not really age aggregated data, so that might not be one of the best ones to compare, but PFOA might be another one that is good to compare. So here we go. Table 1 has PFOS, and table 2 has PFOA, and so you can kind of compare and see what's going on between these two tables, and see even in the total population, the change, in the geometric mean potentially. Seems like in the general population it has gone down, which is always a good sign. And that is consistent through all age groups. Let's make sure. It has in both males and females gone down over the years, and in all races as well. And there's a slight high number in of PFOAs in non-Hispanic whites. Let's see how that compares to table 1, where we looked at PFOS. So definitely trends have really gone down in the total population, which is a good sign. Has 12 to 19 years of age has gone down. 20 plus years of age gone down. Males versus females. Males have a little bit more. And then what's interesting also is that in each gender, each ethnicity, this has gone down as well. But what is interesting is that in non-Hispanic black communities and non-Hispanic white communities, it persistently seems to be higher than in Mexican Americans. This particular chemical, and this may have something to do with the chemical composition. So see, that's a very specific observation, and so that's something that you might want to specifically look into, maybe do a literature review, a literature search, and see if there's a inconsistency in one of the perfluoroalcohol, not PFOAs, and I think it's perfluoroalkyl groups, alkyl. Honestly, lead would have been easier to take a look at, and I think is an important one, and so we can in table 3 just to take a look at lead, and in the total population, lead levels have gone down, which is promising. This one, what I would have liked to have seen actually is more socioeconomic status, because this is very connected to socioeconomic status. But we're just going to make do with the data that we have, and ages 1 to 5. Because lead affects kids, this has gone down, and this data is good to have and look at. Ages 6 to 11, there has been a decrease over the years from. So what this is looking at is between 2011 to 2018. So the top number in each category of 4 is 2011, 2012, and this is 2017, 2018. So that's how I'm understanding the trends over time. So I'm looking at temporal patterns of lead in the total population from 2011 to 2018. So we were at age, I think we were at age 6 to 11. And one thing to note here is the fact that this is something that needs to be followed, actually, is that age 1 to 5, there's more lead accumulation than 6 to 11. And so, and even 12 to 19, lead is lower, mean lead. So 1 to 5, there's more accumulation. And then, of course, 20 and above, there's higher concentrations of lead. But this would be expected with higher concentrations of lead. Okay, so let's see. Males have higher concentration of lead than females, but in both populations, lead levels have gone down since 2011, so that's always a good sign. Now let's look at ethnicity disaggregated data and take a look at what is found. So Mexican Americans have gone down. So the first thing I look at is has this gone down? And so strikingly, actually, what is interesting is that lead levels seem to be quite high among Asians, extremely high in this study group, and so so this is interesting. It has gone down over time, but looking at so when we're comparing all the different ethnic groups, Asian is the highest. The second highest, of course, then is non-Hispanic white, and non-Hispanic black, and all Hispanic. So these are all pretty much close to each other. But lead in Asians is higher. So this is something that should be monitored more closely. Maybe we can get more information from looking at other data sets. So here's one that also shows, here's an additional data set. Now in the urine, it seems like lead, now this is looking at urinary lead. In the urine, lead seems to be higher in non-Hispanic Black Americans. So there's some interesting inconsistencies especially among ethnic groups. And so these are the types of things that you want to be looking for when you're doing research. This is completely unexpected. Before I started recording this, I did not expect to find this, but it's interesting how the measurements are taken, and depending on how it's taken, whether it's through the blood or through the urine, the answer as to which ethnicity has higher concentrations of lead is actually different. And so the reasons behind that would be something interesting to look at. Males, again, experiencing this over females more. Now, looking at lead in terms of age group, seems like 20 plus is the highest. We do see a little bit of a higher sort of lead concentration in ages 3 to 5 and 6 to 11 as well. So that sums up kind of the disaggregated data of looking at multiple contaminants, multiple environmental contaminants. I'm looking at lead, looking at PFAS, and other variables. So when you're looking at, again, chronic diseases, environmental variables are important. National Health and Nutrition Examination Survey is definitely the go-to resource for this, but sometimes you might want to be using this interactive dashboard rather than the actual complete website that's out there. Thank you for listening.